Hi class, this is course 2, lesson 62, classifying triangles. So you're going to make a chart like this in your notes, and we are going to fill in how we can classify triangles by angle measurement or by side length. So this is key. You will have questions asking you to classify by angles or by side length, and so you need to know the different ways that you can do this. So by angle measurement, we can classify triangles as being acute triangles, by being obtuse triangles, or by being right triangles. An acute triangle is going to have all three angles that measure less than 90 degrees. Okay, so let's see. An example might look like that. Nothing special about it, just an ordinary triangle, but all three angles are going to be less than 90 degrees. An obtuse angle, you are going to have one angle and only one. Okay, there can only be one angle that measures greater than, let's see, between 90 degrees to 180 degrees. Okay, not 90, not 180. So let's think like this. Okay, so here's my obtuse angle. A right triangle, you will have one angle that measures 90 degrees. And you know, like that. Okay? Alright, so if they ask you to classify triangles by angle measurement, it'll be either acute, obtuse, or right. If they ask you to classify by side length, we have scalene triangles. We have isosceles. And we have equilateral. Okay, scalene, the side lengths, no sides are the same length. Okay, so like this, whoop. Alright, like this, and like this. Okay, nothing unique about that. The three sides are not the same length. An isosceles triangle has two sides that are the same length. Okay, so you've seen them, they look like this, where this side and this side are the same length. They could also be, you know, like this, where, like a flag, where these two sides are the same length. Just because they're rotated doesn't mean that they're not still isosceles. An equilateral, three sides are the same length. Okay, it's going to look something like that. Better though, because this doesn't look like it's the same, but you will see these tick marks, perhaps, indicating that they're the same. So I did that up here on the isosceles triangle, where they have markings like this. That means that they're the same. This is one mark and one tick mark, they're the same. This one maybe would have 2 and 2, showing that those are the same. Okay, so anytime you see those are tick marks, and they're there to guide you, to help you know that they're the same. Okay, angles and sides can be described as being opposite each other. So in this triangle, angle A is opposite side, and in this case there's segments BC, and angle B is opposite this side, side AC, and angle C is opposite side AB. I'll draw this one in here. Okay, so their sides are opposite each other. Now, here's something that I bet you didn't know. The lengths of the sides of a triangle are in the same order as the measures of their opposite angles. Okay, so what's that mean is the longest side will be opposite the largest angle. Okay, so we don't ever want to just visually look at something without having angle measures, but this side AC looks to me like it might be the longest side, which then would mean that angle B is the largest angle. So let's use this fact to help us figure out the different side lengths. So the lengths of the sides of a triangle are in the same order as the measures of their opposite angles. Okay, so if we know the angle measures, we know which sides are the longest or what order they go in. Same if we know the reverse. If we know the side lengths, then we know the angle order of the angles. We don't know how big they are, but we know the order comparing one to another. So we're going to list the sides of this triangle in order from shortest to longest. But if you look at the triangle ABC, we have angle A is 40 degrees and angle C is 75 degrees. So we first need to find angle B. So let's take a look. How would we do that? Well, we should know that the sum of all of the angle measures in a triangle is 180 degrees. So let's add 40 plus 175, or not 175, 75, and get 115 degrees. So angle A plus angle C is 115 degrees, which we can subtract from the 180 to get 65 degrees. So angle B is 65 degrees. So which angle is the smallest? It'd be angle A, then angle B, then angle C. Now, we want to list the sides in order from shortest to longest. So the sides go in the same order as the angles, but it's the sides opposite them. So the side opposite angle A is side BC. Then the side opposite angle B is side AC, and the side opposite angle C is side AB. Now, let's classify this triangle by side length, and let's classify by angle. Let's do angle first. Okay. Do we have a right angle? No. None of these are 90 degrees, so we don't have a right triangle. Do we have one of these angles that is greater than 90 but less than 180? No. All of these angle measures are less than 90, so by angle it is an acute triangle. Now, to classify by side lengths, we need to know, are all three sides the same length? Are two of the sides the same length? Or are none of the sides the same length? Well, we know that if the angle measures are the same, they would have the same length, right? We can order these by shortest to longest. So if we couldn't say that two were the same length, then we know that none of them are the same length, which makes this a scalene triangle. Okay, here's another triangle. If two angles of a triangle have the same measure, then their opposite sides are the same length. Okay, so here we have a triangle. This is 90 degrees, and this is 45 degrees, and so is this. Which then means, since this is 45 degrees, and this is 45 degrees, that these two sides are the same length. So this is the same as this side. Now, let's classify this triangle by sides and we will classify by angles. Okay, how about by sides? Remember, by classifying by sides, we're looking for the side length. Do we have any sides that are the same length? Yeah, we have two of them. Because the angles are the same, the sides opposite them are the same. Do we have all three sides that are the same? No. So since we only have two that are the same, it is an isosceles triangle. What about by angles? Well, hopefully you notice that we have a right angle, so we have a right triangle. Now, last question for you. What are the angle measures if the triangle is equilateral? Well, let's see. I'll just sketch something out here, and I'll put those tick marks on here to tell you that those three sides are the same. So that means that all three angles have to be the same. Well, the sum of all three angles has to equal 180. So if this plus this plus this has to equal 180, and all three are the same, if I divide this by 3, I get 60 degrees. So each of these is 60 degrees. Okay, I know we went through a lot, and I know that there might be some new information here in your chart about angle measurement and side length to classify triangles. Please refer back to this when they ask you to classify triangles. Okay, if you don't know, please ask, and we will help clarify what's in this chart when you do the problems. Okay, with that, I will see you in class.